Hi guys. So now that we've studied a little bit of chemistry, it's time to talk about how we classify matter. And this crazy looking chart is actually really easy to understand. Let's start together in the middle here with the definition of matter, which I will circle. So matter is anything that has mass or volume, and we can separate it into two really big categories. Here they are: pure substances and mixtures. A pure substance is something that has what we call definite composition. That's that red definition right there. By definite composition, what I mean is that you can see that it has the same atoms together all the time. There's two ways to do this. You could be an element, which means you're found on the periodic table of the elements. So anything that you find on this guy here, right? All of those are the elements. And sometimes the elements will actually hook up with each other, as you can see on the bottom here. You can see that that would still be considered an element, even though those two green atoms, whatever they are the same atom. We call that a diatomic element, di as in two, atomic as in two atoms. But you can also be something called a compound, and we just started talking about this. When we looked at bonding, we saw that, for example, sodium and chlorine bond to each other to form a compound called sodium chloride. So the drawing that I have there has definite composition. You always get one sodium atom with one chlorine atom, and I've drawn that as blue and yellow atoms bonded to each other. Those are pure substances. If you're an element or a compound, it's important to note that you are only separable by doing a chemical reaction. Rx is my abbreviation for reaction. So you can only separate compounds with a chemical reaction, and a compound like sodium chloride behaves very differently than the elements that make it up. So the sodium atom we've talked about behaves like an explosive metal, and chlorine behaves like a poisonous gas, but when they come together to form the compound sodium chloride, they no longer act like themselves. They've become something new. They've become a white powder known as table salt. So those are pure substances. On the other side of the table, we have mixtures. Again, I'll recircle mixtures for you in case you missed that right here. And there's two kinds of mixtures as well. And you might remember this prefix from last year, hetero and homo. Heterogeneous mixtures are mixtures that are different throughout, meaning they are not evenly mixed, they're unevenly mixed. So you can see I've drawn a group of elements here and a compound. Actually, it's one element and one compound. So I have the element that is purple and a compound that is sort of grayish and blue. And they're mixed together, and they're not mixed together in any particular definite composition, so they have an indefinite composition. It changes. And that's pretty common for mixtures. Mixtures are almost always all mixed up, and even though some things may look really, really well mixed to the human eye, at the level of the atoms, they're not particularly well mixed. But sometimes you get really lucky and you get what's called a homogeneous mixture, also sometimes known by this term, solution. Usually you get a solution because something dissolved in something else. And when that happens, the mixing is done really evenly. So this is a totally evenly mixed mixture. Hetero means different, homo means the same, so that's why they're called heterogeneous and homogeneous. Now, let's look at some more examples, because a big part of what you're going to be doing for me is you're going to be identifying whether something is a pure substance or a mixture from a particle drawing. Or the other way around. I might say to you, draw this, and you have to draw whatever the this is. So let's practice doing that for a second here. Okay, so let's take a look at this. So I have right here a collection of particles that I've drawn. how would you classify that? Is that a pure substance or a mixture? Okay, so it's definitely a pure substance, right? It's all one thing. It has a definite composition. So is it an element or is it a compound? It's definitely an element. It's all one type of atom. What about underneath? Pure substance or mixture? Still a pure substance. That's two of the same atoms, they look like. And would you call this an element or a compound? I'd call it an element because even though I have two atoms that are together, they're the same atom. What about over here? What would you call that? Pure substance or mixture? Well, I would call it a mixture because it's two different atoms that are mixed together. The next question is it a homogeneous mixture or is it a heterogeneous mixture? In other words, is it even or is it uneven? So that's a homogeneous mixture because it's evenly mixed, right? I have an exact pattern there. All right, so what I want you to do is actually think about the rest of these kind of on your own. So let me give them letters. We'll call this one A, and we'll call this one B, C, D, and E. See if you can think about what those are for your tutorial note sheet, and we'll see you in class.